Hi, everyone. All right, this is video number 3, writing the equation of a line. Okay, so we know how to look at an equation and tell if we have a tilted horizontal or vertical line. We understand now what slope means. For uphill lines, the slope is positive. Downhill lines, the slope is negative. Horizontal lines, the slope is 0. Vertical lines, the slope is undefined. We know how to calculate the slope using their slope formula. So we're building up. And now we want to know, what if they give me information? I don't have the equation. They want me to write the equation of the line. So they give me information about the line and have me write the actual equation. So this is going to, how we go about it will depend on whether we have a tilted line, a horizontal line, or a vertical line. So remember, a horizontal line has only y. Y equals a number, no x at all. Vertical lines have x only. There's no y in the equation. X equals a number is a vertical line. And tilted lines have both x and y. So we're going to start with the easiest equations to write, and those are vertical and horizontal. With vertical and horizontal lines, we don't have to do much thinking. We don't have to do much analysis, and we don't need a lot of information. Okay. So if I have a horizontal line, I'm going to write y equals some number. I just have to figure out what number to write for the y. Y equals what? For a vertical line, if it's a vertical line that I'm working with, and they tell me that, then I know I'm going to have x equals a number, and that's it. The answer to the problem is x equals, I just have to figure out what number. So horizontal and vertical lines are very, very easy. You've just got to get it straight in your mind, which one is which, okay? So they seem a little bit backwards. A horizontal line is like the x-axis. The x-axis is horizontal. So you need to think about it like it's backwards. The horizontal line looks like the x-axis, but we don't have x equals a number for a horizontal line. We have y equals a number. So it's the opposite letter, the opposite variable. The y-axis is vertical, but we don't use y equals a number for a vertical line. We use x equals a number. So if that helps your brain to think about it as being swapped, then maybe that'll help. I don't know. All right, so on this one, I want to show you this. This is super easy. Write the equation of a vertical. They're telling me the vertical line through this point, -1/6. Well, since it's vertical, I automatically know I'm going to write x equals a number. I just have to figure out what number to put there. Well, what's the x coordinate of my point? The x coordinate of the point is -1. That's the number you're going to let x equal. X equals -1. Done. How hard was that? Now, let me explain to you why we're using the x coordinate. All right, you don't have to graph this in any way to do this problem, but I just want it to make sense in your mind. Okay, so if I plot the point -1/6, I go back to -1 on the x-axis and up 6 on the y, and there's my point. And they want the vertical line that goes through that point. So I kind of missed my mark here on my axis. But do you see how that is going through -1 on the x-axis? Right there. If it goes through this point and it goes vertically up and down, it's going to go through -1. It is the x coordinate. That's the number that you're going to let it equal. Okay. All right. Second example, write the equation this time of the horizontal line. All right. So hold on a sec. Here it goes. Okay. So this time I want the horizontal line. I'll pick an obnoxious green color here. Horizontal line. If it's a horizontal line, it is y equals a number. I just have to pick a number for y to equal. Well, the y coordinate of the point it goes through is 5, and that's the answer. Y equals 5. Horizontal and vertical lines are stupid easy to work with, okay? All right, one more example here with this graph. If I were to plot the ordered pair 2, 5, pretend all of my stuff here looks straight. So 2, 5 would be up here, and I want the horizontal line that goes through that. Do you see how we're going through 5 on the y-axis? That's why we let y equal 5. Silly, silly easy. I hope you're getting it. Okay, now they could also, instead of giving me an explanation or a description, they could give me the picture. Write the equation of the line. Well, here's the line shown. Do you see how this line is horizontal, going flat, straight across like a flat street? What kind of slope does that have? They didn't ask me that. You don't have to answer that. I just want you to be thinking, okay? This has a slope of 0. Horizontal lines have the equation y equals a number. Well, what number am I going to let y equal here? Well, if you look carefully at the grid here, you go down 2 squares to -1, 2 more squares to -2, 2 more squares to -3, which is what our line is going through, 2 more squares to -4. So I go down 1, 2, 3, it's -3. Y equals -3. That's the answer. Do you get it? I hope so. All right, what about this one? This is a vertical line. Clearly, it's going up and down. What's the slope of a vertical line? Undefined. Can't ride your bike up a wall. It has an undefined slope. I know it's stupid, but it'll help you remember. Okay, vertical line here. So I know that vertical lines are x equals a number. All I have to do is pick the number for x. And do you see, we go over 2, this is 1, 2 squares to 1, 2 squares to 2, 2 more squares to 3, 2 more squares to 4. This is 3. X equals +3. That's my vertical line. Okay, so I hope you understand. Vertical and horizontal, if they ask you to graph a vertical or horizontal line, very, very easy. If they ask you to write the equation of a vertical or horizontal line, also very, very easy. Now, more challenging, still not too hard, but more challenging, is what about the tilted lines? If I have to write the equation for a tilted line, I know my equation will have both an x and a y in the equation. So we need to, figure out exactly how to go about it. There's some different options, and we will use these different options depending on the information that is given and how they ask the question. So you need to know that for the tilted lines, there are 3 different formats for writing the equation of a line. The first format is called the point slope form. It's kind of a play on slope. If you can think of it like this. If I write the slope formula, and I then multiply both sides of this equation by the denominator. So I'm going to put that denominator in parentheses and that numerator in parentheses. If I were to go into this equation and multiply both sides by the denominator, well, actually, let me just literally do that. Okay, so y minus y1 over x minus x1, both sides multiplied by the denominator. Then over here on the left, the denominator is just going to cancel and go away, and you have m times x minus x1 equals y minus y1. And that is exactly what we have here. Now, you're not going to have to do that and derive this or anything, but I just want you to see this is not just coming out of a hat somewhere. It's not really a new thing. It really comes from our slope formula. It's just a play on that. And it's called the point slope form because you need a point and a slope to use it. Okay. Now, this is kind of an ugly format. The point slope format is ugly. And we don't ever leave our answer to the question in this form, but it is a starting point for us to find the equation of the line. So this is used to find the equation of a line. So if they start a problem, they say, find the equation of the line that, the first thing that you need to think is point slope form. Okay. Now there are some other things that we might choose depending on the given information, but you can always use the point slope form to find the equation of a line. All right. So point slope form, that's the first format. The second format for the equation of a line is called the slope-intercept form. And basically, anytime you hear slope-intercept form, I want you to think solved for y. Okay? Slope-intercept form means the equation is solved for y. Y is on a side of the equation by itself, and everything else is on the other side. So the slope-intercept form, this is probably the most practical, best form as far as looking at the equation and getting information. Okay? All right, so it's a helpful format to get an equation in slope-intercept form. All you have to do is get the y and the equation on a side by itself. When we do this, then the coefficient number in front of the x, the number sitting in front of x, will be the slope of the line. And b is what we call the y-intercept. We're going to talk about intercepts here in just a minute. But you will have the slope and the intercept clearly seen in this form, and that is why it is called the slope-intercept form, because you see the slope and the intercept in the equation. Okay, the last format is called standard form. To put an equation in standard form, we're going to put the x and the y, all of the x and y stuff on the left side of the equation, and the constant number with no x or y goes on the right. So x and y are on the same side, all of the variable stuff is on one side, and the number is on the other. And so this is a nice, pretty format. It looks nice. However, it doesn't tell you anything. I can't look at this form of the line and tell you the slope. I can't look at this form of the line and tell you right off the bat the y-intercept. I would have to actually go off to the side and do some calculating to find the slope and the y-intercept if it's in this form. So while it looks pretty and it may look like an easy homework problem, it is not a very practical format, okay, for the equation of the lines. Okay, here's a summary of everything. All right, so the top three are for tilted lines, okay, point slope, slope intercept, and standard form. And then the bottom two are for our special lines, the horizontal lines and the vertical lines. So you might want to memorize the equations on this page. It might be very helpful for you when it comes to testing. So make sure you're familiar, okay? All right, now we're going to start out with, we're really focused. We already know how to do the horizontal and vertical ones. So let's go back and really focus on these tilted lines. And we're going to start at the top. If they ask you to write the equation, and keep in mind, they're not going to say tilted. This is a word that I'm using because it helps my brain. They're just going to say, find the equation of the line. If you know it's horizontal or vertical, you already know what to do. If you know it is not horizontal and not vertical, then you have to do a little more thinking, and that's where we are. So if you're going to find the equation of a tilted line, not horizontal, not vertical, you have to have two things. And if you don't have these two things, you can't do the problem. You have to have a point on the line, and that point can be any point on the line. It doesn't have to be a specialized point like an intercept. It can be any point. You need a point on the line, and you have to have the slope of the line. If you do not have these two things, you cannot work the problem. Okay? Now let's say that you do know a point on the line and the slope of the line. What am I supposed to do with a point and a slope? Well, if you know a point and a slope, then you are going to use the point slope formula. The two things that you need are literally written in the name of the equation. So let's say that the point I have, and I'm sorry, my comma for some reason jumped up there. The point is x naught, y naught. And my slope, we're just going to call m, okay? So these are the two things that I have to have, a point and the slope. If I know this information, then we go down here to the point slope formula, and we are going to take the x coordinate of the point that we know, and we are going to plug it into the formula where x naught is. We are going to take the y coordinate of the point that we know and plug that in for y naught. And we are going to take the numeric value for the slope, which we know, and we are going to plug that number in here. So we're plugging in three things. We're plugging in the x-coordinate, the y-coordinate, and the slope. Now, the black x and y are the x and y that are going to stay in my equation. Remember how a tilted line, the equation will have both an x and a y? Well, there's your x and your y for that. Okay, so you're going to plug in three things to use this point slope formula. Let's do an example. All right, write an equation. Let me change to a different color. It's not quite so obnoxious. All right, write an equation in point slope form for the line with slope 6 and through the point to -5. All right, so here's my solution. All right, because the directions have told me to write the equation of the line, I know in my brain, this is me thinking, you don't necessarily have to write this, but I'm just going to keep writing this to pound it into your head, okay? I need two things to do this. One, I need a point on the line. Do we have a point on the line given in this problem? Yes, to -5. And two, I need the slope of the line. The slope given in the problem is 6. As long as you have a point and a slope, you can work the problem. So the formula is y minus y naught equals m times x minus x naught. You've got to know the formula or you can't use it. Memorize the formula. I'm going to plug in the y coordinate and the x coordinate, and I'm going to plug in the number for the slope. All of that information is what we have. So we have y minus the y coordinate of the point, which is a -5. Be careful with that. Don't go too fast because you're going to have a double negative there. The slope is 6, and I have x minus the x coordinate of 2. Now, with the double negative here, we're going to rewrite that and make it y plus 5 equals 6 times x minus 2. Technically speaking, this is the equation of the line. Now, here's the catch. They're not going to let you stop there. They're going to make you put it in a prettier form. So make sure you read the directions before you type in your answer. What does this particular problem say about the formatting? Solve the equation for y. Make it pretty. Put it in the other form where it's solved for y. Get the y on a side by itself. All right, so formatting wise, we're not done. So in order to clean this up, the first thing I'm going to do before I get the y by itself is I'm going to distribute my 6 and get rid of the parentheses. I will have 6 times x minus 6 times 2. And then finally, to get y on a side by itself, we need to move this +5 over to this side of the equation. It is a +5. So when I do move it over to the right-hand side, it's going to become a -5. We're really just subtracting 5 from both sides. And this is y equals 6x minus 17. That's the answer that we would type in and get credit for. Okay, so make sure you read and put it in the form that they want the answer in. So that's the answer. That is the equation of our line. Okay, example number 2. All right, this says write the equation of the line. All right, so again, I'm just jotting some notes down. This is how my brain is working. If I'm supposed to write the equation of the line, I need two things. I can't write the equation of the line unless I have two things. One, I need a point on the line. And two, I need the slope of the line. Okay. All right, let's keep reading. Write the equation of the line in point slope form for a line that passes through the ordered pairs to -5 and -1, 3. Okay, so looking at what I need, the two things I need, do we have a point on the line? Well, yeah, I got overkill. I got 2 points on the line. Pick either one. It totally doesn't matter which one you pick. If one of them looks easier to you, then use it. All of these are integer numbers, so it really doesn't matter which one we pick. I'm just going to pick the first point, 2, -5. Okay. You could have picked the other one. We'll still get the same answer. Okay. All right. So I picked 2, -5. The slope. Now, did they give me the slope? No. In this problem, they didn't say the slope is whatever. So here's how this is going to work. They know when they tell you to write the equation of a line that you have to have two things, point and the slope. They'll either hand you the slope on a platter, like they did in the last problem, and they'll tell you slope is 6 or whatever, or they will give you enough information in the problem to have the slope. So here, the information that I have is two ordered pairs. If I have two ordered pairs, can I get the slope? Yeah, we would use the slope formula. So you're going to use your two ordered pairs that are given to calculate the slope. So this problem has a little bit more work to it than the previous problem because we have to do work to calculate the slope. All right, let's do the work. All right, I've got y2 minus y1 over x2 minus x1. Y2 is 3, y1 is -5, x2 is -1, x1 is 2. So plugging in the points, now we're going to calculate. I'll have 3 plus 5 on the top, double negative there turns into a positive, and -1 minus 2 on the bottom. This will be 8 over -3. So my slope is -8/3. So now I have a point and a slope. If you have a point and a slope, we can use the point-slope formula. All right, so very quickly, we're going to plug in the x-coordinate and the y-coordinate and the number for the slope. Okay, y minus the y-coordinate of my point is -5 equals my slope. This time my slope is a fraction, -8/3 times x minus the x-coordinate of my point. Okay, so let me clean up the double negative first, and then we'll talk about that fraction. Now, there's two ways you can handle this. I really don't care which way you handle it. It really depends on your math skills. I'll show you the way I do it. Now, we're going to do it the brute force way first. So if I have this equation, I could go right over here and I could say, I do not care that this number here is a fraction. I'm just going to brute force it and I'm going to work with the fraction and get my answer. So I'll have y plus 5 on the left. I'm going to distribute the fraction -8/3. So I have -8/3 times x, and then plus 8/3 times 2. Both of those numbers were negative. And so I'm going to write the 2 as 2 over 1. All right, both of the numbers are negative. And so when you distribute it and you have a negative times a negative, that becomes positive. So we get y plus 5 equals -8/3 x plus 16/3. So we multiply fractions straight across. The last thing I need to do to solve the equation for y is to get rid of the 5 on the left-hand side. So we're going to subtract 5 from both sides. So I have -8/3 x plus 16/3 minus 5. Now, in order to combine like terms here, these two numbers, I need to first write that whole number 5 as a fraction, 5 over 1. I need these two fractions to have a common denominator. So let me find a color I can use here. So I'm going to multiply that 5 times 3 over 3 to get a common denominator. And this is y equals -8/3 x plus 16/3 minus 15/3. Well, 16 over 3 minus 15 over 3 is 1 over 3. So y equals -8/3 x plus 1/3. Now, this is one option that you have for doing this. I wouldn't do it that way. I would do it a different way that I think is faster, but we'll see what you think, okay? This is if you don't mind the fractions and working with fractions, you can do it and get your answer. Now, let's say you don't like fractions, which is how most of us are. If you're not real hip to all that arithmetic with fractions, then we can do it. You'll still get the same answer. It'll just be a different way. All right, so let me change over to what color? Blue or something to distinguish. All right, so we're going to start right here in our work. And instead of brute forcing it like we did over here in green, we're going to come down here and do it a different way. And what I'm going to do is say I don't like fractions. So we are going to multiply both sides of the equation by the only denominator in our problem. If you look at our problem here, the only denominator is 3. So I'm going to multiply the left side of my equation by 3. And I'm going to multiply the right side of my equation by 3. And the 3 over here on the right is going to cancel and go away. We just multiplied both sides by the only denominator. Now here's what I've got. 3 times y plus 5 equals negative 8 times x minus 2. I'm going to distribute and get rid of the parentheses on both sides. And now all I have to do is solve the equation for y. To solve for y, we're going to start by getting rid of the 15. We're going to move the 15 over to the right side of the equation. So I'll have negative 8x plus 16. When I move that positive 15 over, it will become negative 15. Combine like terms. And last thing, to get y by itself is I have to get rid of that 3. So we're going to divide everything by 3. So over on the left side, the 3's cancel. I have y. Now, on the right side, what we're going to do is we're going to take that x and the numerator right there, and we're going to very gently shove that x over to the right and just shove it off the fraction and let it sit beside that fraction. And I get negative 8/3 x plus 1/3. And that is exactly the same answer that we got. We just didn't have to do quite so much arithmetic with fractions. It is still work, but distributing an integer number and dealing with integers can go a little bit faster. Maybe it's a little bit easier. I don't care which way you do it. I just want you to be able to get to the correct answer. Okay? All right. So that is example number 2. And this example, it was a longer problem. It was more work because they didn't tell me the slope explicitly. I had to go off to the side and calculate it with my slope formula. Okay, so watch for that. That's probably very common in the homework that you're going to be doing. Okay, next example, very quickly. Write an equation in point-slope form for the line with slope 6. Oh, good. Okay, slope 6. They gave me the slope. I don't have to calculate this time. And crosses the x-axis at negative 3. Now, that's new and different. Okay. So I need 2 things to accomplish the goal. If you're going to write the equation of a line, you have to have 2 things. You need a point on the line, and you need the slope of the line. All right, so this time the slope was handed to us on a platter. Oh, it's not 2 though. I don't know where I read that. 6, okay? So we have the slope, check. Okay, now it says it crosses the x-axis at negative 3. So let's just think about what they're saying. If my line crosses the x-axis at negative 3, now I don't know if it's an uphill line or a downhill line, but it crosses the x-axis right here. What are the coordinates of that point? It is the x-coordinate is negative 3, the y-coordinate is 0. What they're really telling you here is an ordered pair. Okay, so you just have to think about it for a minute. They're giving you the point on your line. Do you understand? Okay, I hope so. Now, this point, when you touch or cross an axis, that point is called an intercept. This is an x-intercept because we are crossing the x-axis, okay? We're going to talk about intercepts more in just a minute. Okay, so now we have this point. So the 2 things that we needed to write the equation of a line are a point and a slope, and now we have a point and a slope. So we can go to our point slope formula and write the equation of the line. So I'm going to plug in the x and y coordinate of the point, and I'm going to plug in the number for the slope. So I have y minus the y coordinate of the point. The y coordinate of my point is 0, equals the slope times x minus the x coordinate. Now be careful, the x coordinate is -3, and you're going to have a double negative there. So I have y minus 0. Y minus 0 is just y, equals 6 times x plus 3. So y equals 6x plus 18, done. Make sense? Okay. So in this case, they gave you information about the point. They just didn't give you the point outright. Okay, so read, just pay attention and see what they're giving you. You need the same two things every time you have to do this. Okay, let's talk about intercepts for a minute. I already mentioned intercepts are where you cross or touch an axis. So let me just do this real quick and see if I can demonstrate. Okay, so if I'm on the XY plane, all right, and I am on the x-axis, I'm just going to highlight a couple of points that are on the x-axis. So if you are touching the x-axis, we call these points x-intercepts. So can you give me the coordinates here? What are the coordinates of this point? This is at -3, so this would be the ordered pair -3, 0. This would be -1, 0. This ordered pair is what we call the origin, that is 0, 0. Here I have 2, 0 and 4, 0. Are you with me? All of these ordered pairs that I have labeled, I have the coordinates for. So what do you notice about all of the coordinates? What do they have in common? The y coordinate for every one of these points is 0. If you are on the x-axis, then you know that the y coordinate, or the y in the equation, is 0. So here's the deal. To find an x-intercept, this is true for lines and for every other kind of function we're going to talk about this semester. To find an x-intercept, all I have to do is go to the equation and let the y in the equation equal 0. Replace every y with a 0 and solve for x. Okay? So to find an x-intercept, you let y equal 0. All right. Similarly to that, if we are talking about y-intercepts, that would be where the graph touches or crosses the y-axis. So again, if we do the same kind of thing and we pick a few points, I know my y-axis is crooked there, but so let's just choose a few ordered pairs that are on the y-axis. This would be 1, 2, 3. This is 0, 3. This is 0, 2. This is 0, 0. 0, -2, and 0, -3. All right, so all of these points, what do they have in common? If I am on the y-axis, then the x-coordinate for the point has to be 0. So if you are on the y-axis, if you're touching the y-axis, then automatically the x-coordinate, or the x in the equation, is 0. Okay? So to find a y-intercept for any equation, if you want to know where it touches the y-axis when you're going to graph it, all you have to do is go to the equation and let the x-coordinate, or the x in the equation, be 0, and solve that equation for y. All right, let's give it an example here. All right, suppose we have an equation. What if I give you this equation? All right, let's say the equation is 2x plus 3y equals 12. All right, if I were going to try to find the intercepts for this equation, first of all, what kind of graph is this? What kind of equation is this? Do you see that x and y are to the first power? So this is what my brain is thinking. I notice that they're both to the first power, so this is linear. I know it's going to be a line. If I know it's going to be a line, is this line going to be tilted, horizontal, or vertical? Because it has both an x and a y in the equation, I know it's a tilted line. Now, what I can't tell you from this equation is whether it's tilted uphill or downhill. I can't tell from this format, but I do know it's a tilted line. Okay, so let's say they ask you to find the x-intercept. They want to know where this line will cross the x-axis. To find an x-intercept, all we have to do is let y equal 0 and solve for x. All right, so in the equation, everywhere I have a y, I'm going to put instead 0. Well, 3 times 0 is 0, and 2x plus 0 is 2x. So I get 2x equals 12. Divide both sides by 2, and you get x is 6. So my ordered pair for my x-intercept would be that x is 6. That's what I found down here at the bottom. X is 6. And I let y equal 0. So the y coordinate is 0. So that's my x-intercept. What if it asked you to find the y-intercept? All right. To find the y-intercept, we let the x equal 0 and solve for y. All right. So everywhere I have an x, I'm going to put a 0. And I'm going to solve this equation for y. So that goes to 0. I have 3y equals 12. Divide by 3 on both sides, and we get y equals 4. So my ordered pair for my y-intercept, x is 0, y is 4. Okay, so one thing that's very clear, you let the opposite variable go to 0 in order to find an intercept. For the x-intercept, you let y equal 0. For the y-intercept, you let x equal 0. When you have an intercept ordered pair, if they give you a point on your line and you have either a 0 for the y coordinate or a 0 for the x coordinate, the 0 in the ordered pair is what tells you definitively that you have an intercept. So if I had, do you remember the earlier problem that we worked where they asked us to find the equation of a line that went through the ordered pair 2, -5? Well, if they gave me the ordered pair 2, -5, is this ordered pair, does this represent an intercept? No, because there's not a 0 at all in it. If you have no zeros, you have no intercept, okay? So just know specifically, for a y-intercept, you have to have a 0 for that x coordinate. That's a really important thing to know. All right, so intercepts are going to be important. All right, let's try another problem here real quick. All right, find an equation in point-slip form of the line with slope equal to 6 and the y-intercept at 1. Okay, so here's the deal. If I'm going to write the equation of a line, I need 2 things. And you got to be careful to not screw this up, okay? You need 1, a point on the line, and 2, you need the slope. All right, well, the slope in this case is given outright. The slope is 6, so that's not a problem. Here, though, they tell me that the y-intercept is 1. The y-intercept. What does the y-intercept mean? Y-intercept means that the x-coordinate is 0. If you want to know the y-intercept, you got to let x equal 0. What they're really telling you here is that the ordered pair that you are working with is the ordered pair 0, 1. We know that x has to be 0 because they're giving us the y-intercept. Do you get it? All right, so this is sort of a second layer of thinking. You've got to be careful to put that 0 in the right place. The y-intercept, if you're touching the y-axis, x has to be 0. So now I've got my point on my line, 0, 1, and my slope. If you have a point and a slope, you can go to the point slope formula and find the equation of your line. You are going to plug in 3 numbers, the x coordinate and the y coordinate for your point, and the slope. So y minus the y coordinate of my point, the y coordinate of my point is 1, equals the slope times x minus the x coordinate of the point. So y minus 1 equals 6x. They want me to solve the equation for y, so we need to move the negative 1 over to the right side. When I move that negative 1 to the right side, it becomes a positive 1, and that is the answer to our question. Okay, so they're going to keep asking you to write the equation of a line. Sometimes they give you outright the point and the slope. Sometimes you have to calculate the slope. Sometimes you have to critically think to get the point. All right, so there's just a lot of different ways that they can tell you how to do this. Okay, now this is using that point slope formula. You need a point and a slope. Those are the 2 things you need. That is the name of the form that we're using. Now there's a second formula for writing the equation of a line, and this is called the slope-intercept form. It is y equals mx plus b. Slope-intercept form means that the equation is solved for y. So if you're ever asked to put the equation in slope-intercept form, all they're asking you to do is solve the equation for y. Okay, y equals mx plus b. When you solve the equation for y, you will have an x term on the right side, and you'll have a constant term on the right side. The x term, the coefficient of x, will be the slope number, and the y-intercept, where it crosses the y-axis, will be that constant b number there. So you just have to be careful. This one is not the go-to to write the equation of a line, because you have to have a very specific point. You can't have just any point on the line. This requires that you have a specialty point on the line, the y-intercept. What do you know about the y-intercept? For the y-intercept, what does the x-coordinate have to be? The x-coordinate has got to be 0. Okay, so it's a very specific point on the line, and you got to be careful to make sure you have the intercept if you're going to use this. Now, if they do give you the intercept, the y-intercept, then you can write it with this format really easy. This is faster than the other format, but you got to have exactly the y-intercept. Okay, here's the example. Write an equation for the line with a slope of 6 and a y-intercept of -2. If they give you the slope and the y-intercept, then we are going to use slope-intercept form. And that is y equals mx plus b. We are going to plug in 2 numbers. We are going to plug in the number for the slope, and we are going to plug in the number for the y-intercept. Okay, so there's 2 things. So the slope in our equation is 6, and the y-intercept in our equation is -2. You literally are going to put 6 here for m and -2 here for b. So our answer to this is 6x minus 2. Don't get confused by that. It is 6x plus whatever the number is. If I do plus and -2, we wouldn't write a plus and a minus next to each other. Plus and -2 is the same as -2. That would be your answer. So if they give you the y-intercept, you can just go right to your line. It's super easy, and I would do that. But this is a very specific thing, and you need to be careful. Here's what I see a lot of students doing. This is why I say be careful. Here's what, after people see that, here's what they do wrong. They read this, they say, write the equation of a line with slope of 6 and this point. And they go, oh, good. See, the y coordinate of my point there is -5. And they try to use this, and they try to put the 6 in for there and the y. They just take the y coordinate of that point and they plug it in here for b. What's the problem with this? is the point 2, -5, is this the y-intercept? Well, the answer is a big fat no. Why is it not the y-intercept? What does the x-coordinate have to be for it to be a y-intercept? The x-coordinate would have to be 0, and this is not a 0. This is not the y-intercept. If it's not the y-intercept, I can't do this at all. You're going to have to instead go back to the point-slope formula and do the equation of the line this way. Do you understand? So be careful. If they hand you on a platter the slope and they hand you on the platter the y-intercept, then you can do the shortcut way, y equals mx plus b. Okay. Now there's some other ways you can manipulate and do and find the, plug in the coordinates and stuff. But to me, the easiest thing to do is to either use the point slope form if you have a generic point and not an intercept, or use the slope intercept form if they do give you the y-intercept. All right, let's talk a little bit more here. All right, here's some examples of equations of lines. I want you to analyze them and tell me about the lines. Line number 1 up here at the top. First of all, this is a tilted line. How do I know it's a tilted line and not horizontal or vertical? Good. It has both x and y in the equation. That does not look right. Let me write that again. Looks a little odd there. Tilted. Okay. And what else do we know about this? What format is this in? Do you see the form? This is standard form. Standard form is where the x and the y are on one side of the equation and the numbers on the other. Okay, what kind of line is the second line? I don't have a y at all. I only have x. This is a vertical line. What kind of slope does this vertical line have? Undefined. You can't ride your bike up a vertical line. That's the one that's undefined, okay? Okay, what kind of line is the third line? This is also tilted, okay? Tilted line. Now, this one, what kind of format do we have here? Do you see how this equation is solved for y, how the y is by itself? That means this is slope-intercept form. Slope-intercept form means solved for y. Now, this is great. This is such a practical format. Because this is solved for y, I can look at the equation and tell you that the slope of the line is 2. I can also tell you it crosses the y-axis at -7. So think about that. I cross the y-axis at -7, and I have a +2 slope. It's going uphill. It looks something like that. I can kind of know what it looks like just by looking at the equation. I can tell you the slope of the line, the slope of the line just by looking at the equation. So you don't have to do any work at all to find the slope if your line is in slope-intercept form. So that's a really helpful thing. If you're given the equation of a line and they tell you to find the slope of the line, solve for y. And then the coefficient number of x is your slope. Okay? All right, so that's what slope-intercept form is for. Slope-intercept form is for looking and finding the slope from the equation. Okay, the next line is y only. This is a horizontal line. The slope of a horizontal line is 0. And then the last guy down here, this is in point slope form. It is a tilted line. Okay, and generally we don't leave our answer in that format. Usually they're going to ask you to either put your answer in slope-intercept form or in standard form. Okay. All right, so what is the slope of the line? Okay, so do you notice that we are in standard form? Can you tell the slope of the line from standard form? No. Standard form is kind of useless. It's pretty, it looks nice, it tells you nothing. What I want to do, all I have to do to find the slope is solve for y. If they give you a line and they want you to find the slope, solve for y. I'm going to solve this equation for y. So I'm going to take the 2x over to the other side. So I'll have negative 3y. Do not drop your negative 3. The negative goes with 3. So when I move the 2x across, I'll have negative 2x, and I have a positive 6 over there. Now, it doesn't really matter if you write the 6 first and you make it 6 minus 2x. I'm just writing the x stuff first because when I put this thing in slope-intercept form, the first term on the left is the x term. That's the only reason I did it that way. Now, to solve for y here, all I have to do is get rid of that negative 3. So I'm going to divide all the way across by negative 3. And I will have y equals, okay, be careful here. First of all, we're going to shove the x off the fraction. Let it sit beside the fraction. I have a negative 2 over a negative 3. The negatives are going to cancel out, so I'll have positive 2/3 x. And then lastly, I have positive 6 divided by negative 3. What's 6 divided by negative 3? Negative 2. That's the equation of my line. Now, from this, when you have it solved for y, the coefficient of x is your slope. So the slope of this line is 2/3. To find the slope of a line, solve for y. Okay? So if it's a tilted line, solve for y. Okay, here's the next example. Again, they give me this equation in standard form. So this is a tilted line. To find the slope, all we have to do is solve the equation for y. So let's solve for y. I'll have 2y. I'm going to bring that negative 8x over to the right side. It becomes a positive 8x. To get y by itself, we divide everything by 2. This one's nice because it works out with nice, pretty integers. I get y equals 8 divided by 2 is 4x, plus 16 divided by 2 is 8. The slope of this line is 4. Okay, next example. What is the slope of the line? Y'all, don't make this hard. Is this tilted, horizontal, or vertical? What do we got here? It's what your brain should be thinking. Look carefully at this equation. Do you see that there is no x? This is y only. This is a horizontal line. I don't have to do one bit of work here, y'all. What's the slope of a horizontal line? 0. Every horizontal line has a slope of 0. So if you can recognize that it's horizontal, you don't have to do any work. All right, last example, I have x equals a number. This is a vertical line. What kind of slope does a vertical line have? Undefined. No work needed. If you know it's horizontal or you know it's vertical, you don't have to do any work to get your slope. Horizontal lines are like flat streets. They have a slope of 0. And vertical lines are like a wall. They go up and down, and you can't ride your bike there. Those are the ones that are undefined. Okay, so I hope this is helpful. We've got one more video left on graphing lines. We'll get that done, and then we'll be done with the section.